Popular theory about our galaxy's fate might be wrong. Astronomers say a collision between our Milky Way galaxy and its largest neighbor, the Andromeda galaxy, predicted to occur in about 4.5 billion years, has been anticipated by astronomers since 1912, but new research suggests that the likelihood of this galactic clash, dubbed Milkomeda, is smaller than it seems. At first glance, it appears likely that the galactic duo, separated by about 2.5 million light-years, is on an inevitable collision course. The Milky Way and Andromeda are barreling toward each other at about 223,694 miles per hour, 100 kilometers per second. However, the local group, or our corner of the universe, includes 100 known smaller galaxies. A team of astronomers factored in some of the largest among them, including the Large Magellanic Cloud, or LMC, and M33, or the Triangulum Galaxy, to see how much of a role they might play on the chessboard of our galaxy's future over the next 10 billion years. After factoring in the gravitational pull of local group galaxies and running 100,000 simulations using new data from the Hubble and Gaia space telescopes, the team found there is about a 50% chance of a collision between the Milky Way and Andromeda in the next 10 billion years. There is only about a 2% chance the galaxies will collide in 4 to 5 billion years as previously thought, according to the study published Monday in the journal Nature Astronomy. A merger of the Milky Way and Andromeda galaxies would destroy them both, eventually turning both spiral structures into one elongated galaxy, the study authors said. Collisions between other galaxies have been known to create cosmic fireworks when gas, driven to the center of the merger remnant, feeds a central black hole emitting an enormous amount of radiation, before irrevocably falling into the hole, said study co-author Carlos Frank, professor at Durham University in England. Until now we thought this was the fate that awaited our Milky Way galaxy, Frank said. We now know that there is a very good chance that we may avoid that scary destiny. However, there are many unknown factors that make it difficult to predict the ultimate fate of our galaxy, according to the study authors. And Frank warns the Milky Way has a greater chance of colliding with the LMC within 2 billion years, which could fundamentally alter our galaxy. Simulating galactic collisions, the LMC orbits the Milky Way, while M33 is a satellite of Andromeda. The LMC's mass is only about 15% of the Milky Way's, but the team found that the satellite galaxy has a gravitational pull perpendicular to Andromeda that changes the Milky Way's motion enough to reduce the chance of a merger between the two giant galaxies. It's a similar case for M33. The extra mass of Andromeda's satellite galaxy M33 pulls the Milky Way a little bit more towards it, said lead study author Dr. Tilsawala, astronomer at the University of Helsinki in Finland. However, we also show that the LMC pulls the Milky Way off the orbital plane and away from Andromeda. It doesn't mean that the LMC will save us from that merger, but it makes it a bit less likely. Previous research also has assumed most likely values for unknown data, such as the uncertainties in the present positions, motions, and masses of the local group galaxies. In the new study, the team accounted for 22 different variables, including those unknowns, that could contribute to a collision. We ran many thousands of simulations, which allowed us to account for all the observational uncertainties, Sawala said. Because there are so many variables that each have their errors, that accumulates to rather large uncertainty about the outcome, leading to the conclusion that the chance of a direct collision is only 50% within the next 10 billion years, in just over half of the simulations predicting what could occur in 8 to 10 billion years. The Milky Way and Andromeda galaxies initially sailed somewhat closely past each other before circling back and then losing enough orbital energy to collide and merge as one galaxy. These initial close encounters between each galaxy's halo, a large envelope of gas, would eventually lead to a collision. In general, the merger would most likely involve a strong starburst during which many new stars would form. followed by a period of intense radiation caused by exploding young stars and the newly active supermassive black hole, eventually shutting down star formation completely, Sawala said. A few billion years later, any traces of the former Milky Way and Andromeda would disappear, and the remnant would be a largely featureless elliptical galaxy. In the other simulations, both galaxies crossed paths without disturbing each other. Geraint Lewis, a professor of astrophysics at the University of Sydney's Institute for Astronomy, finds the results showing the gravitational influence of M33 and the LMC interesting. He has previously authored research on a potential collision between Andromeda and the Milky Way. We won't know if the collision is definitely off in the future, but this clearly shows that the story that people tell, that there will be a collision that will destroy the Milky Way and Andromeda, is not as clear or certain that people think, Lewis said. But even if there is a pretty close encounter rather than smashing head-on, the gravitational tearing that each will assert on each other is likely to leave the two large galaxies in a sorry state. Predicting the cosmic future while including the LMC's gravitational effects on the Milky Way is important. Accounting for uncertainties is the most important aspect of the new study, said Scott Lucchini, a postdoctoral fellow in the Institute for Theory and Computation at the Center for Astrophysics, Harvard and Smithsonian. Here, they've sampled from the uncertainties and the positions, velocities, and masses of the galaxies to obtain the relative probabilities of different outcomes, Lucchini wrote in an email. This really gives us the whole picture of what could happen in the future. Galaxies are full of intricacies. Their shapes can become distorted, interactions can change their orbits, and they can lose mass in different ways. Such complexities make predictions difficult, Lucchini said. That essentially leaves the fate of the Milky Way completely open, the study authors wrote in the new paper. However, more data coming from the Gaia Space Telescope in the summer of 2026 will provide measurements that refine some of the uncertainties about the speed and direction at which Andromeda is moving across the sky, Sawala said. The fate of Earth, the fate of the Sun, may have a bigger impact on Earth's future than the motions of galaxies, according to the researchers. Our Sun is 4.5 billion years old. When it starts to die in another 5 billion years, it will swell into a red giant that engulfs Mercury, Venus, and potentially Earth. According to NASA, the short answer is that the end of the Sun is far worse for our planet than the collision with Andromeda, Sawala said. While that merger would mean the end of our galaxy, it would not necessarily be the end of the Sun or the Earth, although our work also shows that earlier studies that purported to predict precisely what the fate of the solar system would be after the merger were clearly premature. In general, collisions between stars or planets are extremely rare during galaxy mergers. And while the end of the Sun is certain, our study shows that the end of the galaxy is anything but. While the team didn't model a merger between the LMC and the Milky Way in detail, they found a virtual certainty that a merger between the two galaxies will occur within the next 2 billion years, which aligns with previous research, Sawala said. But the effects will likely be more minor than a merger between the Milky Way and Andromeda. The merger between the Milky Way and the LMC will not destroy our galaxy, but it will change it profoundly, particularly impacting our central supermassive black hole and the galactic halo, Frank wrote in an email. He also served as a co-author on a 2019 paper on the potential merger.